In this video, we'll review the point-slope form of a linear equation. The point-slope form of a linear equation is given by the form y equals m times the quantity x minus x1 plus y1, where m is the slope of the line, and a point that the line passes through is x1, y1. Let's take a look at an example. Here we have the equation y equals 3 times the quantity x minus 2 plus 6. Looking at the equation and the point-slope form of a linear equation, we can see that the slope, or m, is going to be 3, the number in front of the parentheses. Looking in the parentheses, I see that we have x minus 2. It should be x minus whatever the x portion of the coordinate is, which tells me that the x portion is going to be 2. So the point is 2, comma, and then looking at the back, we see that it's going to be 6. The point that this line passes through is 2, 6. Here's a few more examples. Identify the slope and the given point for each line. Pause the video, work each out, and then resume the video to check your answers. I'll give you a moment. Alright, hopefully you've had a chance to do this. Let's go through it. In the first equation, y equals 7 times the quantity x plus 4 plus 3, I can see that the slope is going to be 7. It's normally x minus in the parentheses, but it's not, it's x plus. This tells me that the x portion of the coordinate is negative. That's because if you do x minus a negative 4, you would get x plus 4. So the coordinate here is going to be negative 4, 3. In the second equation, the slope is 1/2. Looking inside the parentheses, I see x minus 6, which tells me that the coordinate is going to be 6, and then negative 2. In the last example, we have y equals negative times the quantity x minus 5 plus 2. That negative is like having a negative 1. This tells me the slope of this line is negative 1. In the parentheses, it's x minus 5, which tells me that the coordinate will be 5, and then 2. Now, if you're given the slope of a line and a point on the line, we can go the other way. So if we're told what the slope is and what the point is, we can actually find the equation. This will be the reverse of what we were just doing. So now we're told that the slope of a line is 4, and that the line passes through the point 2, -7. So we can find the equation of this line in point-slope form. In point-slope form, that is y equals m times the quantity x minus x1 plus y1, we're going to go and substitute in our three values. We'll substitute the value of slope, that's the m, and then the x1, y1, which is the coordinate or the point that we're told. If we know that the slope is 4, we know the equation is going to be y equals 4 times the quantity x minus, the x portion of the coordinate is 2, so x minus 2, and then at the end, the y portion is -7. So the equation becomes y equals 4 times the quantity x minus 2 minus 7. Now here's two more examples. Go ahead and try pausing the video, work these out, and then check your work. I'll give you a moment. Alright, hopefully you've had a chance to do this, so let's go through it. If we're told that the slope of the line is 5, and it passes through the point -7, -1, we can go and put this information into that point-slope form. Here, we're going to say that the y equals, instead of m, we'll call it the slope, which is 5. So y equals 5 times the quantity, x minus, now the x value is already negative. So in the parentheses, we're going to get x minus a -7. That's a double negative. And then the y portion is -1. Now we don't want to leave it like this, instead we'll clean it up. That double negative becomes positive, so we can say this is equivalent to y equals 5 times the quantity x plus 7 minus 1. And again, that's how we can kind of see when the parentheses says x plus, we know that that x piece of the coordinate is a negative. The double negative is what makes that x piece plus 7. Alright, for the next one, we're told the slope is -3, and it's passing through the point 4, 3. So substituting these values into the point-slope form, we'll say that it's y equals, substitute the slope is -3, times the quantity, x minus, in this case the x portion is 4, and then the y portion is 3. So plus 3. So the equation becomes y equals -3 times the quantity x minus 4 plus 3. Now, where it gets a little harder is when we're given 2 points but no slope. If we're just told any 2 points on the line, we can still write the equation in point-slope form. To do this, let's look at an example. If we're told that a line passes through the points 3, 5 and 2, 12, but they don't give us the slope, we can still do it. We can still write it in the form y equals m times the quantity x minus x1 plus y1, that is point-slope form, but we're going to have to start by finding what the slope value is. We need to know that m value. And they didn't tell it. to us. All the previous problems we were told what slope is, here we don't have it. So to do that, we're going to change and we're going to find that slope by finding the change in y over the change in x. That is the difference in the outputs over the difference in the inputs. So the slope can be done by taking the y values, that is in this case the 5 and the 12, and subtracting. So if we go, the slope is 5 minus 12 over the change in the inputs. Now here's where you got to pay attention. If we started with the first coordinate, that is the 5 value, and from that we subtracted 12, we got to make sure that we go in the same order. If we start with the first point, here colored in purple, and then from that subtract the second point, which is in green, we need to make sure that for the x's we do the same order. We need to go purple minus green, or first coordinate minus second coordinate, which means we got to go 3 minus 2. Now you could reverse the order at the top, but then you'd also have to reverse the order at the bottom. We could also say the slope is going to be 12 minus 5, but then on the bottom we'd have to go 2 minus 3. The order matters. It's always the change in y over the change in x, but when you do the coordinates, you just got to go in a certain order. Whatever order you pick on the top, same order on the bottom. Now simplifying this fraction, we're going to see that 5 minus 12 is going to be negative 7. Whereas on the bottom, we get 3 minus 2, which is positive 1. Simplifying one more time, negative 7 divided by 1 gives us a slope of negative 7. And we can substitute that value in. Now as far as which point we pick, it could be either one. We could pick either the 3, 5 or the 2, 12. So substituting, y equals negative 7 times the quantity x minus. If we pick the first coordinate, we're going to say it's x minus 3, and then plus 5. Now like I said though, we could use the other coordinate. The slope would still be negative 7, but instead in the parentheses we'd have x minus the 2, and then plus 12. Now these equations may look different. I see different numbers for the x and y values. However, they are equivalent equations. If we were to distribute the negative 7 and combine like terms, we would see that both of them would have the exact same value. We call that equivalent. Here's 2 more examples. Go ahead and try each of these. Take the 2 points, find the slope, and then once you know the slope, substitute that slope value and either of the coordinates into the point slope form to find the equation of the line. Pause the video one more time and try this on your own. Resume the video when you're ready. Hopefully you've had a chance to do it, so let's go through it. To find the slope, because we need that for the equation, we're going to start by subtracting those y values. Here, the y values are 3 and negative 6. So the slope, m, equals 3 minus a negative 6 over 4 minus a negative 2. The double negative up top becomes 3 plus 6, which will be 9, over 4 minus a negative 2 becomes 4 plus 2, which is 6. 9 6 can be reduced, becomes 3 halves. Divide top and bottom by 3. If the slope is 3 halves, we can substitute that in. Into the equation, we now have y equals 3 halves times the quantity x minus. Pick either coordinate. In this case, I'm going to do the first one, the 4, 3. So we get y equals 3 halves times the quantity x minus 4, and then plus 3. Again, we can pick either point. We can also say it's y equals 3 halves times the quantity x minus the negative 2 becomes x plus 2, and then minus 6. So that would look like this once we simplify it. Again, the equations may look different, but they're not. They really are equivalent equations. If we were to distribute the 3 halves and combine like terms, we would see that both the y equals 3 halves times the quantity x minus 4 plus 3 and the y equals 3 halves times the quantity x plus 2 minus 6 have the same value. So either one is fine to use. In the last one, we're going to do it same form. Start by finding that slope value, the m. It's going to be the change in y's, which is 1 minus 15, over the change in x, which is negative 8 minus the negative 1. In the numerator, we're going to say 1 minus 15 is negative 14. And in the denominator, negative 8 minus the negative 1 becomes negative 8 plus 1, or negative 7. Dividing the double negative here, the negative divided by a negative becomes positive. 14 divided by 7 is 2. So the slope is positive 2. Substituting in our values, we get y equals 2 times the quantity x minus. We have a negative 8 in the first coordinate, so we can say x minus a negative 8, double negative, plus 1. Rewriting that double negative becomes y equals 2 times the quantity x plus 8 plus 1. And that'll look like that. Again, we can use the other coordinate, but I've done enough examples with that. Now the last thing we're going to look at is how to graph using point slope. And it really is a pretty easy thing to do. Point slope is really useful when it comes time for graphing. All you need to know is any point on the line and what the slope is. So to do this, I would really like that you copy down these steps. Know how to do this, write the steps down so you have it to something you can go back and refer to later on. So the first thing, if you've given an equation in point-slope form, you want to identify or find out what is the slope in the given point. So look at the equation, find your m value, that's your slope, and the point that they're giving you. Write them down. And then we're going to go ahead and plot that given point. Whatever point they tell us is going to be our starting point. We're going to put that point on the graph. Now to graph a line, you really only need 2 points. So to find another point, we're going to take that point that we're given with, that's our starting point, and then we'll use the slope to find another point. Now it's a good idea to get at least a third point, because sometimes when the points are kind of close together, we take our ruler, we try drawing it, our line can drift from where it needs to be. If we get 3 or 4 points, it makes it really easy to make sure they all line up, and we're putting the line where it really belongs. So once you've found the slope and the point, plot the point, use the slope to find a second or possibly a third point, and then take your ruler and draw the line. You want to make sure you're using a ruler so you get a nice straight line. All lines should be straight. Let's look at an example. In the equation y equals half times the quantity x plus 4 plus 1, let's start by finding what the slope and the given point is. We can see that the slope is 1/2. In the parentheses, it's not x minus, which tells me the x portion is negative, so the point is going to be negative 4, 1. We're going to set up our graph, which means we're going to label and scale it. The label refers to the axes. We need to say that the horizontal, or the input axis, is x, and the vertical, or output axis, is y. So we put the x and y where they belong. The scaling is putting what the numbers are, or how we're counting. We want to make sure that we count on the lines. So notice in this, I've actually counted the 1, 2, 3, 4, and so on the lines. Don't just go to the end and somewhere close to, or the end, put a 5. That's not going to be good enough. It needs to be on the line. So let's start by finding the point negative 4, 1. If we plot the point negative 4, 1, means from the origin, from 0, 0, we're going to go 4 units to the left and 1 up. That's right here. To find the other points on the line, we take that point and we're going to start traveling by whatever the slope is. If the slope is 1/2, that means we go up 1 and 2 to the right. And up 1 again and 2 to the right. And there's my points. I can take my ruler and draw a nice line now. Here's the line y equals half times the quantity x plus 4 plus 1. We want to make sure that we identify it by writing the equation next to it. Pause the video and let's try that last example on your own. When you're ready, resume and check it. Now I'm running out of time, so I got to make sure we get this. So let's go ahead and try it. The slope is negative 3. The coordinate is going to be 4, negative 2. Take your graph, label and scale. Plot the point 4, negative 2. That's going to be 4 units to the right of the origin and down 2 units. That's right here. To find the other points, we're going to take the slope. The slope is negative 3, which means we go down 3 and 1 to the right. Now it looks kind of weird. Negative 3 is not a fraction, but we can treat it like one. Any whole number can be divided by 1. So if we go down 3 and 1 to the right, there's the point 5, negative 5. Now I don't have enough room to go down again, so instead let's go the other direction. Instead of going down and to the right, we can also do the opposite, which would be to go up and to the left. So if from the original point, that is the 4, negative 2, if we go up 3 and go 1 to the left, that'll be another point on the same line. Here's the line. That's the line y equals negative 3 times the quantity x minus 4 minus 2. I hope this video helped you to understand how to do point-slope form of a linear equation, and thank you for watching.